Welcome back to Intrinsic. As we left off calculating future free cash flow based on a average growth rate to feed into our DCF model. We're going to continue right along with getting the number of outstanding shares. We also need this key figure for DCF. I'm going to get the outstanding shares from this website, company's market cap. They have, for example, Apple as of October 2024. So we're going to get that value. We're going to import requests, and from BS4, import beautiful soup. We're web scraping it because, at least for me, I did not see the outstanding shares value in Yahoo Query or Yahoo Finance. If it is in there, I would love it if you let me know in the comments. Maybe I missed it. But we're going to use Beautiful Soup to grab the outstanding share value. So for the URL, we're going to use fstring to make it dynamic. And then we're going to get a response from this website when we make a GET request. And then URL, we can check and make sure the response is healthy. Request is not defined. It's because I need to put an S in there. Okay, so response of 200, that's good. That means there is a healthy response and we're connected. So I want to then parse the HTML. So let's call it soup, and using Beautiful Soup, we're going to take that connected response that we have and analyze the content of the web page. And we now have the HTML of the website in the soup. And then we're going to find the element that contains the number of shares. So it's going to be in a span class of background YA. So if I go to inspect, there it is. Background YA, we want class background YA. So this is what we're going to be looking for there. So we're going to go in here and then say shares outstanding element is equal to soup dot find the span class underscore, and as we saw, it was background dash YA, and then shares, we're going to call it shares outstanding dot text dot strip if. So this way we can say if it doesn't exist, then bring back not found. If it does exist, give me the text in that class. And then now we could just print out the outstanding shares, and that doesn't work. Couldn't find a tree builder with the features of HTML parse. Oh, the error is there. Oh, parser, excuse me. Gotta add an R in there. And there you go. So this is the outstanding shares of Apple as of October 2024. So that matches. But the issue here is that this is a string value. Obviously, we want this as a numeric value. So we can make a custom string to number function. And we could do a variable of S. And then we could say try return the integer value. We could say we don't want these commas because that's what's causing it to be a string. And we could say replace it with nothing. And then accept. we could say try to return a float in case we are unable to get it as a integer. This will allow our function to be good at error handling. And then finally, we could do another value error. So if it's unable to do an integer or a float, then it probably means that the variable is not compatible to become an integer or a float in the first place. So we'll then say error. We'll create our own custom error message, unable to convert to a number. Okay. And then return none. So now I could just overwrite this. Well, actually, I'll call it number just so that we don't confuse ourselves. And then we'll take our brand new custom function and then grab this guy because this is the string version of it. And then there you go. So we just had a string version and then we turned it into a number. So now we could chug it into our DCF model. Now, I also want to get the WACC. However, there are ways to calculate WACC on your own. For example, what you would need is like market value of equity. So that's the stock market capitalization. You also need the market value of the debt, total value of capital, which is market cap plus total debt value, and then cost of equity, cost of debt, corporate tax. So there's a lot of elements that are part of a WACC calculation. For now, I've been trying to scrape the value from valueinvesting.io. Unfortunately, I've been getting a 403 error, so they seem to not like it when I tried to web scrape. So, for example, I tried building this scraper here, but if I try to run it, symbol is not found. Oh, I need to run this entire. Sorry, I got to run this entire thing. Okay, so WACC value was not found. So I was like, okay, that's weird. What is the response like? And it clearly doesn't like me, right? 403. So unlike the 200 that we saw with the first website, I'm unable to get a healthy connection with investing.io. So maybe WACC could be a future video that I produce to use the financial statements to calculate our own WACC. But for now, I'll manually type in 8.6 when we calculate the intrinsic value of Apple. And this will be something in the future that we visit. That way, we can finally get to the meat of the bone, discount free cash flow function, because this is where the stuff is at. In order to calculate this, we're going to need to first calculate the present value of free cash flow. So this is used calculating the current value of the future sum of money or list of cash flows, which we just calculated the future free cash flow list. We're going to use the discount rate on that future money, which is the WACC, because that discount applies to future money since money in the future is worth less than today. So we're going to first create a present value custom function. And the formula for present value is the summation of free cash flow over 1 plus R, R being the discount rate, so that 8.6%, and then T is the time period. We did future cash flows of 5, so 5 years. So we are going to return the comprehensive list. So this is going to be list comprehension. The free cash flow at I divided by the 1 plus the WACC. And I need that to be lowercase, WACC I plus 1. And then for I in range, the length of the future free cash flow list that we created. So for example, why don't I say present value is equal to the free cash flow, which is our future free cash flow list that we created in the first episode of this discount cash flow series, and then 0.086 for 8.6%. And then this will give us the present value if I don't forget a comma. Okay. So this is the present value. We converted the future free cash flows that we estimated using a average rate growth model, and then we converted it into present values. So this list is going to feed into our discount cash flow, so DCF custom function. We're going to need the free cash flow, the WACC, the terminal growth rate, the net debt. We also captured net debt in the first video episode of this series, and a number of shares outstanding, and then shares outstanding. Okay, so we can take this guy and put it within our function. That way you could do the DCF once. So we'll say present value of the free cash flow. We'll take away these values and we'll say FCF and WACC. Next step. Okay, so this was step 1, which is calculate present value. Step 2 is to calculate the terminal value. Okay, so what is terminal value? After the forecast period, it is common to assume that the company will grow at a constant rate into perpetuity. The terminal value represents the present value of all future free cash flow beyond the forecast period. So for model simplicity, the forecast will assume a constant rate. So the formula for terminal value is the free cash flow multiplied by 1 plus G, G being the long-term perpetual growth rate, and then all over WACC minus the long-term perpetual growth rate of G. So let's put that into Python. I'm going to say terminal value is equal to FCF and -1, because we want the most recent free cash flow. 1 plus the terminal growth rate. On average, it's about 3% for this growth rate. And then WACC minus terminal growth rate. And that should be it. Okay, so step 3, we need to calculate the present value of the terminal value. The terminal value needs to be discounted back to the present, similar to free cash flow using WACC, because again, money in the future is worth less, so we need to discount it. So we want terminal value all over 1 plus WACC, and then the number of periods as the exponent. So calculate present value of terminal value. So present value of terminal value is equal to terminal value all over 1 plus WACC. I keep capitalizing it. And then the length of the free cash flow, since we're doing 5 years. Step 4, we need to calculate enterprise value. How do we do that? Enterprise value, we need to sum up the forecasted free cash flow and the terminal value. So the sum of these is our enterprise value, or EV. So all we would have to do is present value free cash flow plus the present value of the terminal value. So enterprise value is equal to sum of PV FCF, which we've calculated here as a list. And then we will say plus the present value of the terminal value, which we calculated in step 3. And then step 5, we have calculate the equity value. So this is where our company's net debt comes in. We will take EV minus net debt for the equity value. Since the debt is considered the liability, we would have to take it out. So in that case, we will do equity value. I meant to type that in this line. So we'll say get equity value. So equity value is equal to the enterprise value. Enterprise value minus the net debt. Step 6 is calculate the intrinsic stock price. So this is where the goal of this video is. If I could spell intrinsic value of a stock price. And this is where the number of shares outstanding is important, since we are going to take the equity value in today's present value and divide it by the number of shares outstanding to get how much a individual stock should be worth according to our discount cash flow model. So intrinsic value, actually I'll call it intrinsic stock price, is equal to equity value divided by the number of shares outstanding. And then our model will return the intrinsic stock price. Okay, so let's say print. Okay. Better yet, we'll make it pretty and say print intrinsic stock price is there you go. So this way it'll look like a dollar value and it'll be easy to read. All right, and now moment of truth. We will say we'll call the DCF model that we just created and say give me future cash flow of future FCF. We're going to say the WACC is 0.086 as we saw from investing.io, we'll say that the terminal growth rate is equal to 0.03. 0.03 for terminal growth rate is industry kind of standard, so we'll stick with a conservative value. We'll say net debt is equal to net debt, and then number of shares outstanding is equal to the number of shares outstanding. And that is not defined because I need it as a number. Oh, that's also not defined. Oh, great. Oh, it's because I'm silly. Shares outstanding number. That's the name of our variable. So now once I hit enter, we will get a intrinsic stock price for Apple is supposedly $165 a share. And if I type in Apple stock, we will see that Apple is, according to our model, it's overpriced. So currently Apple's at 230, and our discount free cash flow model says that Apple's stock price should be at 165, assuming the future free cash flows that we calculated are indeed true, and we performed present value and applied the appropriate WACC and terminal growth. So this is the bones of a discount cash flow model. Of course, as I highlighted previously, using an average growth rate as the forecast for future free cash flow is not the most sophisticated. This model doesn't consider seasonality. It doesn't consider for probability, likelihood of, free cash flow increasing like this almost at a straight line, right? This doesn't really look realistic, right? You're going to see seasonality, you're going to see bumps in the road, you're going to see declines, you're going to see stagnation. But either way, there are rooms for improvement of this model. Perhaps I could revisit this video to automate a way to get WACC or calculate it using the financial statements that we've gathered from Yahoo Query. Another thing to note is that we only have so much history using Yahoo Query. If you would like to upgrade this discount cash flow model, if you want to upgrade it based on the data, you could look into other APIs like Alpha Vantage. They have like 25 requests per day that's free, and they offer a lot of historical fundamental data like balance sheets and income statements and cash flow statements that may be helpful, because Yahoo Query from Yahoo Finance, they only provide like 5 quarters worth of data. So it's not, 5 years worth of data is not that much, to go off of. So I would definitely say ways to improve this bare bones model is better historic data, more historic data, a more sophisticated forecasting model instead of just average growth rate, and then automating the get WACC function here. But other than that, you have now a custom DCF model, and you now have the bones of finding potential intrinsic value based off discount cash flow. And if you want to put meat on the bone, there's definitely ways to improve it. So I hope you enjoyed this video of discount cash flow model. I would love to make a part 3 by improving on the flaws of this that I have mentioned. So make sure to subscribe and don't miss out on another coding video. I'm curious what other coding videos you would love to see. Would you like to see more fundamental analysis coding videos? Would you like to see more technical analysis videos? Maybe algorithmic trading videos, things like that. Love to hear your thoughts and feedback on that. So thank you for coding with me. Thank you for hanging out with me here today at Intrendias. Check out Intrendias.com for free buy and sell signals on your favorite stocks, cryptos, and Forex. And I will see you guys in the next one.